Hi class. Before we move on to the next step of kinematics, uh, I would like to divert and cover a mathematical concept that we'll use throughout this course. This mathematical concept is called vectors. Very simply put, vectors is simply a representation of some quantity along with a direction. And one useful analogy to draw on an example for what a vector is a displacement. So let's say you want to say that a gas station is 3 kilometers to a friend. So your friend is run out of gas, and you say, well, there's a gas station 3 kilometers away. Well, if you hope for this friend to be able to reach the gas station, this is not enough information. So you have to tell this person some sense of direction. And you could say, if this is the case, that it is 3 kilometers east. Now, when we use this, so when we go ahead and use this direction convention, we are assuming the usual east, west, north, and south that represents directions on a map or a GPS. In this class, we will not always have access to this way of defining directions. So in this class, the way we're going to define directions is we're going to use the Cartesian system. And what I mean by Cartesian system is simply you have two lines 90 degrees to each other, and you're going to denote one direction x and one direction y. This is an introductionary physics course, so all of our problems from now until the end of the semester will have at most two directions or two dimensions. So let me show you a couple of examples on how to write some simple vectors in this format. So let's say we have vector A. And we are going to denote a vector by some variable and an arrow on top of this variable. Your textbook uses bold letters. However, when you're trying to write on your homework, or when I'm trying to write over here, it's really impossible to do it in an efficient way, in an efficient and clear way. So we're going to stick with this arrow here. So let's say we want to draw a displacement here, or some sort of quantity that is 3 units, and it points in the x direction. Arrows are great geometric representations of what vectors are. So here you can clearly see it's an arrow. It's 3 units long, and it points to the x direction. And the way you write this algebraically is 3x plus 0y. And this part over here really is almost like a recipe on how to draw this arrow. Note how x and y has these hats, and that's just basically saying, look, anything that has a hat is nothing more than me saying which direction in a Cartesian it is. It is not a variable that you can manipulate the way you do regular variables. So this is a recipe. You go 3 units on the x direction, 0 units in the y, you draw it, and that's what you get. All right, so let's do another vector. And let's say that we want to write algebraically what b is. And so let's say that b is a vector that is 4 units, and it points in the y direction. Good. So what we're going to say here is that this is 0 units in the x, plus 4 units in the y direction. Again, it is more like a recipe on how to draw this arrow. So far, so good. I want to show you something called vector inversion. So I'm going to take A, and I'm going to write what minus A is. And since this is an equation, the minus gets applied to both sides in the algebraic way. And so you can think about it as minus 3x direction plus a 0y direction. The problem is that the way we define vectors is that it is a length and a direction. If you note here, x and y, they are directions themselves. And the combination of these two directions gets any direction that you'd like. However, now I have a length of minus 3. And the way we reason through this is to say, well, you can have a length of minus 3, but what you can do is you can have a length of 3 in the minus x direction plus 0y. And how does that work is if this is the plus x direction, the other way is going to be the minus x direction. Same thing here with the y direction. If you have positive y on the top, you have a minus y opposite to it. And now all of a sudden it sort of makes sense. 3 in the minus x direction means that in the opposite direction in which x runs, and its length of 3, and this arrow here is what we call minus a, right there, while this is just the arrow a. So this is the, so right down here is the algebraic representation of these things, and this is geometrical representation of this. The next thing I would like to do is I would like to show you how to add vectors. So I want to focus on two arrows now. I want to focus on arrow A right here, and arrow, and this was B, arrow B right here. Note how A is to the right, B is up. And vectors are objects that you can move, meaning that as long as the length of the arrow and the direction of the arrow is the same, I can move the arrow A or the arrow B anywhere in this Cartesian system. So what I'm going to go ahead and do is I'm going to write A, but I will start A at the base here. That's where it is. I'm going to leave B for now. What I will show you first is how to add these two vectors algebraically. So vector A plus vector B. This is equal to, I will just write down algebraically what A is. It's 3x direction plus a 0 in the y direction. Now I'm going to go ahead and write what B here is, plus 0 in the x direction plus 4 in the y direction. And the way you add these vectors is every number or quantity that is tagged along with the x's, you sum them. So in this case, you have 3 plus 0. So I'm going to get the x direction here. X 3 plus 0. 3 plus 0 is just 3. Now the other component, you do the same thing. So what you're going to do is you're going to take, you're going to group all the y components together. So you have 0 in the y for A and 4 in the y for B. 0 plus 4 is just 4y. So A plus B is a 3 in the x direction plus y in the 4 units in the y direction. And if I do a graphical representation of this, I'm going to call this vector C. So C is just the add of A and B. And the way I write this is 3 units in the x direction and 4 units in the y direction is right there. And I just connect where I started from all the way to the point. So this is a C. So I made a very special choice here. I could have drawn C anywhere because it is just an arrow that is 3 units in the x direction, 4 units in the y direction. But again, I didn't say where the arrow was supposed to start or end. I just chose this point right here. And what I want to show you here is that if you now look very closely, you will probably see that, let's see here. You see that when you connect this point right here to this point right there, you will go no directions in the x, and you're going to go 4 units in the y. So 4 units in the y, no direction in the x, that's precisely B. And there you have it. So we showed algebraically that a plus b is 3x plus 4y. But what I want to also show you geometrically is that when you add the a and b, all you would have to do really is start with a and draw it beginning at the origin, and then just stack. So then just stack b here at the tip of a, and now where you started your drawing to the end of the second vector b, you draw a line, and that's vector c. So you can do this geometrically or algebraically the way I did this over here. I can also show you how to subtract vectors. Subtracting vectors is a lot like addition, and I'll show you a trick. So let's say that you want a minus b. A minus b. What you can also do here is you can do an algebraic manipulation that a plus minus b. And what by that means is you can go ahead and draw a Cartesian coordinate system. And then you can go ahead and draw a normally, the way you would just do the addition here. You can draw a right there. But now we're not drawing b, we're drawing minus b. And if you remember a minute ago, we said that whatever you do with the arrow when you reverse a vector is that you flip it on the other end, which means that if positive b points upward, then negative c or negative b points down, and that's negative b right there. And so a plus b, so let me show you the two resultants here. This is what we just did a second ago. That was a plus b. Now we have a different vector that came from a minus c, and that or a minus b, and that's this one, and that's a minus b. So a vector addition and vector subtraction is they're very close as far as algebraic or as far as geometric alterations. It's just that the second vector, you just flip them upside down. The final note I want to make about vectors that becomes especially very useful in this class is the use of trigonometric functions to be able to deal with them. So let's again go back to this method here, or this example. So let's say you have a vector a here, same as vectors a and b. And then I have a vector b over here. and then vector C over there, C over here. What I want to point out to you is that this is a 90-degree angle. And this over here, you can draw, so this is a 90-degree angle, which means this internal angle here is a very special angle. So the last notation thing that I want to go through is that if A is the vector, then when I write A just by itself without the arrow, is going to be the magnitude of the vector, or the length of the vector. Meaning that if vector A was 3 units in the x plus 0 units in the y, it means that you don't have to do any mathematics here. You can just say that here A is just 3 units long. Right. So if I go ahead and do that and just draw this as a triangle, the triangle I'll get is simply A, B, and C, with an angle here, and this is 90 degrees. And some trig here that would come really useful in this class is C squared. It's going to be A squared plus B squared. That is Pythagorean theorem. The next thing is the trig functions. So the sine of this internal angle here is opposite B over the hypotenuse, which is C, and the cosine of the angle is the adjacent. It's A divided by the hypotenuse. And finally, the tangent of the angle is the opposite, B over the adjacent, A. Now, with the previous examples for A and B, meaning for A equals to 3x, and for B equals to 4y, see if you can use one of these mathematical functions to figure out the length of C. So find out what C is. And give yourself a minute. You can pause the video, try it out. Okay, this should have been a very simple thing for you to do. And if it is not, then I would highly recommend you take a little bit of time this week to review trigonometry. So the way we would do this is you can note that because A is only one direction and so is B, means that A is 3 units long, B is 4 units long, therefore C squared equals to A squared, which is 3 squared, plus 4 squared. And what you find is that this will lead to C having 5 units. And again, if you are having problems going from this line to this line, this is more of an algebra exercise. So if this is difficult for you right now, I'd recommend you also doing some algebra review this week. Okay, so this covers vectors and everything you need to know to apply vectors or to understand how vectors are going to be used. I would use this video as needed as you progress through the course, and I will build more examples on vectors as we need. So the next thing we will talk about is velocity, and velocity will be a vector. Therefore, you will have some examples of how velocity is used in that context. Thank you very much, and I will talk to you very soon.